Good morning, good afternoon, good evening, good wherever you are, and welcome to this SNIA Cloud Storage Technology Initiative presentation. Why use multiple clouds? And I'd like to welcome today a couple of really good speakers. We're going to be talking with Mark Carlson, who's going to do a first part of the presentation. Mark is the co-chair of the SNIA Technical Council and works for Kiotia. Good morning, Mark.
Good morning, Alex.
And we're also joined by Greg Turetsky, who's Principal Product Manager at Seagate Technology. Good morning, Greg.
Hi, Alex.
At least I presume it's morning where you are. It's evening where I am. I'm Alex McDonald, and I'm the SNIA CSTI Chair, and I'm an independent consultant. Anyway, welcome, and particularly to those of you who I've not spoken to so far, a Happy New Year to you. As we get into 2022, I hope it's a better 2022 than it was a 2021. So really quickly, SNIA at a glance. What is SNIA? It's 180 leading industry organizations with about 2,500 contributing members and about 50,000 IT end users and storage pros worldwide that join us on a regular basis, you being right now one of them. You can learn a lot more about SNIA's activities at snia.org/technical, or you can join us on Twitter at SNIA. The Cloud Storage Technologies Initiative does quite a lot of stuff to do with, basically, as you can probably imagine, cloud storage. That's the primary focus for this group. What we're trying to do is educate, support and promote, understand and collaborate. And in those four areas, education like this plays a very important role. And it provides us with a way of making sure that people understand the technologies that they're looking at and does so in an industry neutral way. What we're not attempting to do when we present for SNIA is sell you anything. All we're trying to do is make sure that you understand the technology, understand the concepts, and that we're adding value to any conversations you might have with other parties when you go out and look for cloud storage solutions or cloud technologies in general, in fact. Just a very quick SNIA legal notice. I'm not a lawyer and I don't play one on the internet either, but basically this presentation, if anything you do with it causes whatever you're doing it to break into two parts, both of those parts are unfortunately yours, not ours. There are no warranties, express or implied. And we would like just to point out that this legal notice is there simply to make sure that we retain some control over how the materials are used. And we thank you for honouring the copyright that we have in them. So today's agenda, very quickly, is really quite simple. We're going to be talking about 5 areas. We're going to be talking about risk reduction. How do you reduce risk by using multi-cloud? Cost reduction, always another great topic of conversation. How do you make sure that the costs are manageable? How do you make sure that you continue to get the kind of features and performance you want as you move into a multi-cloud environment? And inevitably there will be challenges in doing so, and we'll discuss some of the challenges and we'll have examples to give you so that you can take those away and think about them and perhaps try and match them up with what you're attempting to do in a multi-cloud environment. So without further ado, I'm going to let Mark take over and talk about the justifications and benefits of multiple clouds. Mark, take it away.
Thanks, Alex. Well, the biggest reason I think why people want to use multiple storage clouds is to escape the lock-in that individual cloud providers try and get you to do. As you build on the technology from a single cloud, you are essentially tightly coupled to that one cloud provider via that API that you coded to. So moving to another cloud requires development work on their API, which can be expensive, can take a long time to complete. And because of the differences in the APIs between multiple clouds, you may need to re-implement some of that cloud functionality on another cloud before you can move. So what helps this is to have a storage abstraction layer. that you put in front of all your clouds, which then insulates the application from that underlying cloud provider's interfaces that lock you in. And this allows an application to store and access data across multiple clouds. The placement of that data can be transparently changed without having to modify the application as a result. And this reduces or eliminates the cost to exit any given cloud once you've coded up this abstraction layer for a new cloud. And this ensures that applications are not tightly coupled to cloud-specific technologies. The other reason is to avoid single points of failure. As people have seen, cloud outages are quite common. And what do? How do you reach your customers if the primary cloud that you're working on goes down? Well, you need a second cloud that's still up. And so applications that are built on a single cloud are dependent upon the reliability and availability of that cloud. And there's ways to increase your reliability and availability within a single cloud by using different regions. But spanning more than one cloud really increases its reliability, availability, and performance, and enables greater control over the cost versus reliability, availability, and performance trade-offs, because you're not trying to do that within a single cloud. There's also political, regulatory, and compliance restrictions on where your data lives, and that changes over time. The storage abstraction layer allows data to be evacuated or moved from cloud to cloud transparently. An example is data is governed by different regulations and can be placed in different clouds that are compliant with those regulations, such as Europe. And when cloud storage is not acceptable, you can store that data on premises, again, transparently because of the storage abstraction layer. And then there's operational cost reduction. There's an opportunity to take advantage of lower cost service offerings on a different cloud than what you're using today. It minimizes paying for service level objectives that are not required. Then the data can be transparently moved from cloud service to cloud service. And essentially, when egress costs are less than the potential service. And then the cost to exit is when you want to pull your data out and move it to a different cloud. What are the costs? There's the development costs to develop to the new cost. There's the egress costs from that cloud to another cloud. Those are all costs to exit a cloud. But using an abstraction layer, in addition to things such as Kubernetes, enable you to package up your workload and move it between clouds. And multi-cloud storage makes this much, much easier. What about running work in parallel across clouds? Applications built on a single cloud must process data in the cloud where the data is stored. But multiple clouds take advantage of lower computing costs, available computing resources, running processing in multiple clouds in parallel. Approach does not work well for large data sets where cloud resident application must access the full data set. The storage abstraction layer allows connections of data to be stored together on the same cloud. Computing performed on that cloud can be performed against locally stored data through, again, this abstraction layer. This provides transparent access to remotely stored data for computing in any given cloud. It also enables transparent migration of data when computing moves from cloud to cloud. There's also a situation of hybrid cloud and bursting to cloud. Supporting the storage abstraction layer allows a uniform data access on premises and in the cloud, which may mean mean that it's much easier to burst to the cloud when on-premises capacity is exhausted. And also things like remote batch execution using cloud resources as well. And then access to cloud-specific features. Features that are present only on a given cloud can still be taken advantage of without having to use that cloud exclusively. Excuse me. Allows those cloud storage features to be specific to a cloud, exposed in a standardized manner via a standardized API, allows data to be transparently accessed and migrated, and moves the application from being aware of the underlying mechanisms. And then there's latency reduction. When storing the same file in multiple clouds, a simultaneous request can be made for the file from each of those clouds. The first response can be used to satisfy the request. Other requests can be aborted to save egress charges. Can be hidden behind a proxy CDMI, which is the Cloud Data Management Interface Server. So applications need not do anything different. So this is running a CDMI server, perhaps on your own premises, that can access both local storage and remote storage. If it's stored locally, it satisfies the request quite quickly. If it's stored remotely, you're still going to get it down. You're still going to put a copy on premises, acting kind of like a little cache to reduce the latency further for further operations. And there's also a possibility of throughput increase where you can have storage objects on premises are accessible to multiple clouds. Hard limits can be exceeded, increase the aggregate total throughput. Storage objects can be sharded and erasure coded. And then you can do parallel requests to each cloud to return the shards. If you get a sufficient number of shards returned, the object can be reconstituted. Other requests can be aborted. And the workaround for individual cloud providers bandwidth limits. So you can get aggregate bandwidth from multiple clouds that exceeds any given one cloud provider's limitations. And then sharding also increases the security since no one cloud has all your data. And then the egress cost reduction is made available because cloud providers have varying charges for egress. Some cloud providers may not charge at all for egress. So if you put your data in multiple clouds, one with charges for egress and one that doesn't, the cloud with the lowest egress charges can be used to fetch the object. You still have the no single point of failure of your data in multiple clouds, but you can have the cheapest way to get your objects implemented.
Mark, thank you. Just very quickly, not very quickly. We got a little time here. I've got several questions.
Sure.
Let me start with the first one. Way back when the universe was about 5 or 6 years younger, and you and I were sat down talking about the CDMI interface, we talked about, we actually had some idea that we might have multi-clouds and that we would be able to benefit from vendors providing competitive services but based on the same technologies. Do you see that in the market at the moment? I mean, are we seeing vendors providing alternatives, for instance, that provide the same interfaces, but alternatives that are cheaper and selling them that way? I don't want to mention any company names, but I will, because it's almost inevitable to avoid it. Amazon, for example. Are there any competitors to Amazon that are out there simply saying, we can offer this equivalent Amazon service for a lot less than Amazon offer it?
Well, so almost all cloud interfaces are based on HTTP or HTTPS. And so the way you put your data into the cloud and the way you get your data out of the cloud is all based on HTTP. So they all have that in common, and that is also in common with the CDMI interface. But almost always, once you get beyond putting your objects in and taking them out, how you manage your data in that cloud, how you get it to receive the service levels you want, how you get it to receive the reliability and availability that you want. All that is done via proprietary interfaces.
Mm-hmm.
And there's not always a good mapping between the two. Uh, and some clouds use metadata on the HTTP messages. Others use JSON objects. CDMI standardizes the JSON that is used to manage your data in the cloud. And so if you can have your applications using a standardized interface instead of the proprietary interface part of it, you can actually abstract it away to the point where it is the same service in both clouds. So
Okay.
whether you're running locally using CDMI or you move to the cloud and use CDMI, you're essentially abstracting away all the proprietariness of that cloud.
Okay, thank you. So a couple of others. Somebody asks, and I'm going to part of bad joke here. Ask not for whom the egress tolls, it tolls for thee. They're looking for an example of a cloud vendor who does not toll or charge for egress of data. Are there any?
Yes, there are. One example would be LiveCloud. They charge only for consumption capacity, but not for egress.
Ah, there we go. So there is an example of that. And I suspect this one will probably be answered. Greg, if you could just keep it in mind as we go through your section about adding cost and complexity from a security perspective. For example, many separate security offerings, none of which cover end-to-end cloud solutions. Cloud vendor A may have a different security requirements and SLAs from cloud vendor B. So I suspect security has always been a big issue, but in this case, it may be worth trying to cover it as we go through your part of the presentation. But for the moment, what I'm going to do, I'm going to hand over to Greg, who's going to take us through multi-cloud challenges and some usage examples. And if he doesn't answer that observation about security, I'll make sure I ask you again at the end, Greg. Take it away.
Thanks, Alex. So, yeah, great to talk to the forum here. There are many benefits of using multiple clouds, as Mark shared. There are obviously some challenges as well, as many of you are definitely aware. First of all, every cloud provider is developing a solution that is working when customers are working within the same cloud. Going cross-cloud results in very differences in manageability. So APIs vary between different clouds. The functionality of similar things may vary in details. And when you start looking into the multi-cloud setup, you should be well aware of those differences between the APIs and management interfaces. Security, as somebody asked here, is definitely a big topic that has to be addressed. Every cloud provider usually has a good security model with access controls and permissions and authentication and so on within the cloud. When you go to deploy application in the multiple clouds, addressing the security aspects in the cross-cloud setup may require more effort. And also the audit, collecting information and auditing the access and the events in multiple clouds may require more work. Another potential challenge is the interoperability. Deploying the third-party applications and expecting that it will run the same way in multiple clouds, this may require more testing and more validation. Using managed services, even if they are available for multiple clouds, may also require more effort. Controlling the cost with every cloud, every cloud provider today offers a pretty comprehensive set of tools for tracking and controlling costs. How you do this across clouds, controlling your costs, controlling your spending across multiple clouds might be a challenge. And egress, for those who charge, or most of the providers do charge for egress costs, but not all of them, may become a challenge. Again, should be.
Greg, while we're here talking about egress, I think the name of the company that you mentioned, and I will point out there are probably many of them, but somebody's just pointed out Zadara is another one that doesn't charge for egress. Which one was the one you mentioned? Is it Leaf Cloud?
Live Cloud. It's a Seagate Live Cloud offering.
Live Cloud. Okay.
LYV.
Right, but there are many.
There are others, yes.
For instance, the Oracle, for instance, doesn't charge for the first, for instance, 10 terabytes. But so there are all sorts of options available for egress, zero cost. Thank you. Sorry, Greg. Carry on.
Okay. So yeah, controlling costs across clouds is something that requires attention. And last but not least is getting the right talent. Every cloud provider today has multiple offerings, and the number of the amount of innovation and new services coming from every cloud every year is very significant. So hiring the right talent that can really speak multiple cloud languages, if you wish, and also keeping them all up to speed with the changes happening in the cloud becomes another challenge. So all those things have to be taken into consideration when planning for multi-cloud architecture. But if you do, you can really benefit from applications running in multiple clouds. So let's take a look on some of those examples of how people do multi-cloud storage. And I'm not going to talk about the names, but each one of those examples is actually a real setup that somebody is doing in production. So the first example here, I call it shared multi-cloud storage. It's a storage that is actually stored in a single cloud, but it's accessed by an application that runs in multiple clouds. And the use case here is rendering basically a movie or commercials at a lower cost. And the customer here is looking for reducing the cost of compute, and they rely on the spot instances offered by different clouds, right? So different hyperscalers today, they have different ways to charge for compute instances, and one of those is what is called kind of preemptive instances or spot instances, where you can offer your cost, which would be usually much lower than the standard on-demand price, and bid for the lowest cost systems. The systems can be terminated by the cloud provider if somebody else is coming in and is willing to pay more. So as long as your application is ready to run in this environment and can be reprovisioned and restart, this might be the great way to save cost. And what the customer wanted to do is to leverage spot instances not only within a single cloud, but to go and use it across multiple clouds. The challenge is really to ensure that the input data is available, for instance, wherever it comes. And the way the solution was actually economical is because it was mainly read focused, right? So all those applications, all the workload is doing mainly read for the input data and clouds. And so they were able to run this workload across multiple clouds and read data from a single shared cloud provider. Another example is a distributed multi-cloud storage. So in this example, we saw a scientific project that included collaborators from multiple institutions. And each one of those institutions had their own sets of data in different clouds. So the challenge was for all those organizations to build basically an abstraction layer, a single namespace that would allow the researchers from different teams to access the data across multiple clouds to do this cancer research in this case. So they ended up building an abstraction layer for all those separate parts of the entire storage environment. They had to implement a global authentication mechanism that would authenticate people from different organizations with the ability to access to this data. And the applications that they used could access data in the uniform way because of this abstraction layer across multiple clouds. The workloads were doing mainly read from anywhere, but writing the results preferably to the same cloud where the actual application is running. Again, reducing the egress costs. And in this case, every object is stored within a specific cloud and can be accessed from any specific cloud. And this is a third example where yet another customer, and I call it here for the sake of this presentation, dispersed or maybe sharded multi-cloud storage. The customer was looking for a secure archival storage. And one of the concerns they had was they didn't want to rely on one particular cloud provider to store all their data. So what they prefer to do is to leverage multiple clouds and store the data sharded. So no single cloud provider has all the pieces of the data. So again, they built an abstraction layer for this cloud agnostic data access, and they used it to stripe data across multiple clouds. So every cloud gets a chunk of the data. It's also encrypted, but for additional security, they basically wanted to store it sharded between clouds. And to get access to the entire object, the application needs to read it from multiple clouds or multiple regions of a cloud to get the entire object. So those are some of the examples of what is being done with multiple clouds. There are definitely many other examples of use cases of what people are doing with multiple clouds. To summarize the talk, we see that the multi-cloud infrastructure is a reality for multiple companies, especially as we consider hybrid cloud as the specific case of a multi-cloud. If you have your on-premises data center and some of your workload is running in a public cloud, it's also a case for the multi-cloud that may provide the same benefits or subset of the benefits we talked about, and also may have some of the challenges that we discussed. It's very important for the organization to have a multi-cloud strategy to address those challenges. And if you use a common abstraction layer for storage and maybe other APIs that are needed within the cloud, it may ease your multi-cloud adoption. Back to you, Alex.
Thank you, Greg. I've got lots of questions. And it goes back to your first slide, and also every slide that you mentioned from that first slide onwards. The first slide mentioned talent, which I believe there is a terrific lack of. Oh, you're about to take us back there. Yeah. And the second thing you said was abstraction layers. Presumably somewhere there is talent developing and delivering these abstraction layers. I mean, this sounds like a terrific, not overhead, but overhead in terms of function, but overhead in terms of cost. Presumably these abstraction layers cost money to develop. I mean, are there any open source ways of doing this? Are there any commercial systems that allow you to do this? I mean, what's the answer here?
So there are many different companies that are trying to address this. If we talk specifically about things related to storage, first of all, there is the open standard with CDMI that has been driven by SNIA. There are other solutions that are available that may be more focused on more proprietary protocols. So one example is the MinIO that can be used as a gateway for Azure and Google Cloud storage, and provide S3 protocol access for those object storage solutions as well. So you get kind of the AWS compatible S3 API to Azure and Google, and can use native S3 in AWS. There are other solutions from platforms from other vendors. So NetApp has come with this kind of multi-cloud integrations that provide that up under the hood and in different places and others.
Okay.
You can use file system as an abstraction layer, right? And you hide any cloud operations under that file system. And filers have been doing this for years.
Yeah.
Does that simplify the security implications of this as well?
As long as you get, it depends. It may make it easier if you have the same storage solution that has the same security model. You may still need to address the directory services and kind of how to manage the accounts across multiple clouds. If you also build an abstraction for that, then yeah, it can be addressed.
And I suppose one of the follow-on from that would be, okay, so if we're building stuff like this, I'm presuming that we can take our applications and do the same thing. So, I'm thinking of Kube environments, Kubernetes environments. Mm-hmm. The abstraction allows you to, for instance, move entire, not just storage, but entire applications from one place to another, where you might have different interface models. Is that the case? I can abstract away the application as well.
So yeah, that's definitely a great case, and I think we mentioned it somewhere in the slides. Kubernetes gives this abstraction for the compute migration. You can easily move your workload between different clouds and on-premises, leveraging Kubernetes. And then the multi-cloud storage gives you an answer for the data movement. If you can access your data from multiple clouds, then moving this application workload using Kubernetes becomes very easy. So this example that I mentioned, for example, here with the multi-cloud rendering, the actual workload was running in Kubernetes using different Kubernetes services in different clouds, but consuming the shared storage.
Okay. So I'm going to take it just to the slide at the end. Just let me take it to the slide at the end, because I want to try and just do a summary of this. There's also what I suspect is a bit of an inflammatory statement on this slide, which says hybrid cloud is multi-cloud. Is that because the technologies are the same, or because you really believe that multi-cloud is simply a subset of hybrid cloud, or hybrid cloud is a subset of which is it? Because the industry tends to use the two terms differently. They're not seen as interchangeable.
Well, it's the abstraction layer that lets you do this. I mean, there's a big benefit to having some of your data sitting locally on your premises for whatever reason. But the application is going to get much better latency to local data than it does to cloud data. And it still papers over the differences between how you're storing locally and how you're storing in the cloud. So, you can do multi-cloud without having any data on your premises. But look at what benefit having that data locally gives you.
Mm-hmm. Mm-hmm. Yeah, I just think I get a sensation. There's a sense that we've confused. Not we collectively in the industry, may have confused the issue with hybrid cloud and multi-cloud. We've not been particularly clear about our terminology here, and the two appear to be being used quite differently in different circumstances. Okay, thank you, Mark and Greg. Thanks for viewing this webcast. We'd love it on the way out if you rate the webcast. In fact, there's one thing I'm going to do. I'm going to go to the next slide first. There's actually a quick poll question we'd like you to do, and you'll find there's a QR code here. If you point your phone camera at it, you'll be able to get the survey monkey that it points to, or you can type it in if you're of such a mind. But basically, that survey allows us to get some feedback from you about what clouds you're using today and what platforms or solutions that you might be looking at or are looking at to abstract multiple clouds. And we'd be grateful if you could actually complete the survey. That would be very helpful to us. I'll move back away from it, but I'll leave us on that slide in a second. But just let me move back. A webcast and a copy of the slides is also going to be available in the SNIA Educational Library, which contains, by the way, a huge amount of information about storage in all its varieties, a terrific resource a terrific educational resource that we have at SNIA. The slides are also available, as has been shown on the tab earlier, on the tab that allows you to get attachments. And you'll see a copy of the slides there for your use. We're also going to post a Q&A from this webcast. We'll take the questions that we got today, and some that we didn't, because I still got a number of questions I'd like answered, and post it up on our SNIA Cloud blog at sniacloud.com. You can also follow us on the Twitter SNIA Cloud.
Also, I'd like to mention that the work on multi-cloud is going on in the cloud storage technical work group inside of SNIA, and we could use more help on working on the multi-cloud effort. So if you're interested and you're a SNIA member or want to become a SNIA member, please consider joining that cloud twig and helping us out.
Yes, thank you. That's a good point, actually. Thank you, Mark. So in the meanwhile, I'll leave you sitting on this particular QR code that will take you to the survey. If you can complete the survey for us, that would be terrific. I'd like to thank both our speakers today, Mark Carlson from Kiosia and Greg Turetsky from Seagate, for helping us understand a little more about how we might use multi-clouds in our environment and giving us some examples of how they can actually bring benefits to some of the workloads that you might be anticipating. We've got one last question. I don't know whether it's... right. No, it's not a question. It's just an observation, but thank you for it anyway. Somebody's saying perhaps hybrid IT is a better way of thinking of it. That could be the case. Yeah, no, absolutely right. Another piece of terminology for us, but quite a good point. But anyway, thank you very much today for coming along. And as I say, please fill in the survey and please help support us by looking at the education material that we have on the SNIA website. In the meanwhile, whatever your day holds, I hope it's a good one. And thank you very much indeed for coming and listening to us today. Goodbye now.